Hey everybody, it's Mr. Kinney here. We're gonna go over we're gonna do any corrections or just confirming if you had the correct answers to moles, molecules, and atoms, also known as lions and tigers and bears. Okay, no, sorry. So let me zoom out now. And I'm going over this just to make sure that you had it set up right. So I'm gonna do two things here. First, well, no, I'm just gonna go over it. I'll talk a little bit about each one. Now I've already got these completed. And they're in red ink, so hopefully. So on this first one, we'll zoom out a little more. So we did this one in class, but the main thing is we are looking in this one, we want to find the number of number of moles. We're given the number of molecules. So what we have to do is, and I've got this little graphic, now this will be in the notes that we're doing today, but part of a triangle we've learned is that when you go from moles to number of particles, number of atoms or molecules, when we're going from molecules to number of moles, we are going to divide by Avogadro's number. If we are going from number of moles to how many particles, we multiply by Avogadro's number. So in this problem, all of these are number of molecules or atoms, and we're figuring out how many moles. So we're going to take what's given, and then this is our conversion factor we're going to multiply it by, but really what we're doing is we're taking the number of particles and we're dividing it by Avogadro's number. So in this one, you should have had this all set up. Now it's kind of one thing you can do if you don't have a calculator is, well, I won't go into that because you're going to all be able to have calculators. We've got this number set up. Now one thing you can do too is like those 23 zeros, I can take away 23 of those zeros there, leaving me just one zero, which is this 10. And it really makes this number, 3.6 times 10 becomes 36 divided by 6.02. I mean, this answer really basically becomes 6 moles. I mean, you don't even really need to use your calculator if you're comfortable knowing that. You take those 23 zeros, get rid of 23 of them up there, and we're just left with that. So for number 2, so we're looking for atoms of iridium, and you divide that is Avogadro's number of iridium atoms in 1 mole. And with this one, now look at here, the times 10 to the 23, you could cancel that with this times 10 to the 23, and this problem really becomes 9 divided by 6, which can reduce to 2 over 3, which becomes 1.5. So you end up with 1.5 moles. A lot of these problems, you don't even really need a calculator if you're comfortable with crossing off. Number 2. So we've got molecules of water. Well, we divide by Avogadro's number as we've been doing. We can cancel those off, of course. And on this one, now the times 10 to the 23, the times 10 to the 23, this problem really becomes 3 divided by 6, which is a half. Oh, let me zoom out. Sorry about that. There we go. So you end up with 0.5 moles of water. For number 4, so we've got this many atoms of aluminum. We're dividing by Avogadro's number because that's how many atoms of aluminum are in 1 mole. And let's see, the atoms of aluminum cancel, we're left with moles. And on this one, I mean, even on this one, you could, if you didn't want to enter all the numbers in your calculator. Oh, now look at here. There's 10 to the 23. If I get rid of 23 of these zeros, that's going to become, 25 minus 23. That basically makes this times 100. Now, if that's too hard, don't do it. Just enter it in your calculator. And if I multiply this number by 100, it becomes 163 divided by 6. If that's too hard, don't do that. But it's a lot easier to do 163 divided by 6 than having to enter those in your calculator. You should get about 27 moles of aluminum. Now over here, we're looking for a number of atoms, and actually I can cross off the atoms. They're all going to be number of molecules of each of the quantities. So number of molecules in each of these. Now we're starting with moles in all of these. Let me verify. Yeah, and so what we're doing is, to look back up here, whenever you go from moles to number of atoms or molecules, you're going to now be multiplying by Avogadro's number. So for each of these, we're multiplying. So 5.5 times 6 times 10 to the 23. Now let's see. Moles of CaCO3 cancels out, and we're going to end up with 3.3 times 10 to the 24, and that should be molecules of CaCO3. Left off the right over there. And number 6, again, we're multiplying by Avogadro's number. The moles of calcium of copper chloride cancel off. And it becomes, really comes out to, it's 6 times 0.2, which comes out to be, and then times 6.02 times 10 to the 23, it becomes 1.2 times 10 to the 23 molecules of CuCl2. We've got 901 moles of iron oxide, or rust. 1 mole of rust is equal to that many molecules of rust. I've already canceled those off. So this problem is going to become 901 times 6 times 10 to the 23. So that 900, that gets converted into those decimals over there. So 5.4 times 10 to the 26 molecules of iron oxide. And our last practice conversion here, you had 1.2 moles of methane gas, CH4. Well, 1 mole of methane is 6.02 times 10 to the 23 molecules of methane. And when we do the math on this, 6.02 times 1.2 turns out to be 7.2 times 10 to the 23 molecules of CH4. I really should write those out, but I didn't. Lastly, find the number of oxygen atoms in each of these below. So it's a little different. We're starting off with 10 moles of water here. And we know 1 mole of water has 6.02 times 10 to the 23 molecules of water. Now this moles, we can cancel those out now. So at this point, we've just converted it into molecules. Now we're going to say 1 molecule of H2O has 1 atom of H2O, because that's what we're eventually looking for. Remember, in these problems, these are the givens. You need to make sure you know what you're looking for. We're looking for a number of oxygens. And so 1 atom of oxygen and 1 molecule of water. Molecules of H2O cancel off. And what we end up getting is going to be, let's see, we don't have to worry about the ones. It's going to be 10 times 6.02 times 10 to the 23. That's just going to make this 6. And if you did 6.02, that's all right. But 6 times 10 to the 24 atoms of oxygen. Atoms of oxygen. Number 10, half a mole of calcium carbonate. Well, 1 mole of calcium carbonate is that many molecules of calcium carbonate. Moles cancel out. In 1 molecule of calcium carbonate, there are 3 atoms. So you've got to make sure, okay, there are 3 atoms of oxygen in every molecule. So we got 1 molecule is 3 atoms. Now we can cancel off molecules here. And our answer is going to be 0.5 times 6.02 times 10 to 23 times 3. Now, oh, I didn't do the math on that. Oh my goodness. Oh my, I need a calculator here. Yikes. Well, I'm going to just do a quick guesstimate. 0.5 times 6, that's going to make that basically 3. And 3 times 3 is 9. Times 10 to the 23 is what I'm guesstimating. Let's see. Turn on my calculator. And I'm going to put 0.5. Well, let me make sure I clear it first. It'd be embarrassing if I had something off. Clear. There we go. 0.5 times 6.02. Put the EE button. 23. That means engineering exponent. Times 3. And 9 times 10 to 9.03. Okay, 9 times 10 to the 23 atoms of oxygen is what we end up with. You want to be real specific. Okay, 9.03, but that's all right. So coming on down to here, that's what we got here. 20 moles of magnesium hydroxide. And let's see, so we've got in 1 mole of magnesium hydroxide, we've got Avogadro's number. We can cancel those out. And then coming over here, we've got 1 molecule of magnesium. Sorry, that was so messy. That's why you should always use a pencil. Magnesium hydroxide. There are, well, let's see. There are 2 atoms of oxygen. So 1 molecule MgOH2, 2 atoms of oxygen. The molecules cancel off, and we're going to have, well, let's see. 20 times, let's see, 2 times 6 is 12. 12 times 20 is like 240. Then we got to mess with, so it's going to be something like 2.4 times 10 to the 25th. That's going to be my quick guesstimate, but you know what? I always use a calculator because I don't always do stuff quick in my head. Times Avogadro's number, 23, times 2 atoms, equals 2.4 times 10 to the 25. Don't be impressed. It took me like 52 years to learn this, so you're probably getting it already. All right, 15 moles of calcium phosphate. Well, we know 1 mole of calcium phosphate has that many molecules of calcium phosphate. And now we got to be careful here, because phosphate itself, one phosphate has 4 oxygens, but this molecule has 2 phosphates. So it's going to be 4 times 2, it's going to be 8 atoms of oxygen. So we can cancel the molecules with molecules, and we're going to have 15 times Avogadro's number times 8 atoms per molecule of oxygen times 8 equals 7.2 times 10 to the 25 atoms of oxygen in 15 moles of calcium phosphate. Oh, please tell me that's the end. It is! Hurrah!